Hello, my name is Stephen Hutt, and today I'm going to be talking about our paper, Breaking Out of the Lab, Mitigating Mind Wandering with Gaze-Based Attention-Aware Technology in Classrooms. So our vision for this technology is that students would be interacting with an intelligent tutoring system in the classroom, in our case, Guru, a biology tutor designed for high school students. As they do this, their eye movements would be monitored through some low-budget eye tracking technology. Here we use the iTribe, which retails for about $100 per unit. We would then detect instances where the students were mind wandering, build some kind of intervention, and have the intelligent tutor deliver that intervention. Now, in previous work, we've taken care of the early parts. We have the tutor, we'd integrated eye tracking, and we're able to detect mind wandering. This work focuses on what to do next. How do we respond to student mind wandering? And so we designed interventions. To do this, we turned to the experts. We consulted with teachers and with students about how to reorient student attention. And we designed two types of intervention: a repetition intervention that consisted of an attention redirection phrase and a repeat phrase. So here we would repeat the information that was being covered when the student was detected to be mind wandering. So here might be the original text that the tutor was saying, a student's detected to be mind wandering. So we say, let's go back over that. This will be on the quiz later. That's our attention redirection phrase, and then we repeat the above content. Our second intervention was a question, again using an attention redirection phrase, but then using a content question. This question was still based on the content that was being covered when the student was detected to be mind wandering. So you see again, we have our attention redirection phrase, but the second part here is phrased as a question. We tested this first in the lab with undergraduate students, then with high schoolers in a one-on-one basis. We then explored how well this would scale to a classroom pilot with 13 students, and finally to a broader user study. And this testing process helped us make sure that our interventions were not abrupt, but they were still noticeable, they didn't disrupt the learning experience or damage the interaction, and that we were using high school friendly language. And so our first user study, we were interested in, are these interventions actually reducing mind wandering? And what we saw was, yes, mind wandering predictions following the intervention were significantly lower than those prior to the intervention, suggesting an encouraging reduction in mind wandering. That led us to our second user study, which was going to examine, are these interventions boosting learning for students? We did this with 184 students. Data was collected over 4 days, and each student completed approximately 3 sessions each. Now, you may notice the mathematics doesn't quite work here. Not all students got 3 sessions due to classroom interruptions, students being late, having to leave early, etc. And for this experiment, we had multiple conditions. We started with an intervention condition. That's kind of everything I've talked about so far. Students' eye movements were monitored, mind wandering detected, and interventions delivered accordingly. Then we had an active control. Was the simple act of an intervention, be it correctly or incorrectly timed, having an impact on learning? So here students received interventions randomly, not based on their eye movements. And finally, a do-nothing control, where students received no interventions at all. Of sessions in our intervention condition, 155 had no interventions at all. So we separated those out as a intend to treat, leaving 172 sessions with at least one intervention. We then further split this into students with exactly one intervention and students with more than one intervention. We had 2 measures of learning in this work, a post-test and a delay test. The post-test was completed immediately after the Guru session. The delay test was completed 1 week later. And through statistical analysis that's detailed in the paper, what we learned was that our interventions were supporting low prior knowledge students. And this effect was specific to the delay test that measured long-term retention. The students took 1 week after the session. And so more broadly, what we're seeing is attention-aware learning technology is feasible in complex environments such as a classroom. Our work has shown that our simple interventions could reduce mind wandering and boost learning for certain populations. And with that, I'd like to thank my collaborators, as well as our funders, and you for listening. Thank you very much.